myself and ourselves. So my name is DELL. I'm working for DELL. I'm in a regional position, so I'm working with customers from Cyprus, Malta, Greece, and up to the Baltics. So mainly in the CE countries. We have around 30 languages, which is challenging, and not the top 10 languages, which is also challenging, because in the AI world and in the large language models world, everybody is talking about the new improvements and possibilities, but when we see what is the actual possibility in non-English language, then we will have some challenges. Apart from those challenges, we also have other types, for example, the budget, we have the time frame, the knowledge, the people, so we have a lot of challenges that we need to talk about. My team is called HAPC, we like the abbreviations. The HAPC abbreviation means HPC, AI, R&D Cooling Specialty Team, because in many aspects or many times we find that if the customer wants to implement an AI system with, let's say, 8 GPUs, then alone that server consumes 10 kilowatts of power, 10 kilowatts alone this server. So if we don't want to use an angle grinder and cut it to half because of the rack possibility, which is in average 3 to 6 kilowatt per rack, then we need to solve the power and cooling issue. So it means that we manage the power and cooling together with the AI solutions. Nowadays, it's a really interesting curve where the AI is, and we think that everybody is going towards the ChatGPT for prototyping or other cloud-based solutions, but when realizing that solution is not exactly the solution they want. For example, they need to fine-tune. If you read that verse there, you will find out also yourself that it needs to be some kind of fine-tuning. Then you will realize that even that Starship is not so nice Starship, and maybe it will not give you the value that you aimed for. And now the value to look for the value is really important. What do I mean? It means that even the smallest systems are beyond around 200,000 euros, up to 1 million euros or 10 million euros. So if you want to implement a system, then you need a strong business case. It also means that either you have some kind of loss in your company and you want to tackle that loss, I mean, you want to reduce the loss with some kind of AI-based system, or you want to bring additional value to your company. So when going there, you need to find out what is the best possible choice. Today we will talk about a lot of agenda points, so maybe it will be fast. If it's faster than you want to be, then please ask questions, raise your hand to stop, raise your hand to rewind, or something like that. We will talk about some business cases, frameworks, MLOps, so machine learning operations applied for the LLM systems, guardrails and firewall sizing, performance tuning, and we will talk about, naturally, about data. So, what is their added value? Their added value is manifold. So we have innovation centers, we have a lot of good people, we have experts. In the CE region, we have around 120 experts. Sorry, not CE. In the MR region, we have 130 experts who are dealing with AI-based systems. And alone in the CE region, we have 7 AI experts that are able to help you on your journey. Apart from that, we have the possibility to try out things. So our main purpose now to make proof of concepts, because we think that making proof of concept will be helping you to evaluate your business cases. Then we saw the large language model size is 1 year ago. It's really important that it is March 2023. Then we saw that picture. The largest large language model was some kind of that one or one, so 540 billion, which is insanely low nowadays. But 1 year ago it was very large, and all the other language models were a bit smaller. When we saw the same picture in December, then we saw that the 500 billion or 300 billion models are some kind of mid-range models. We have small and extra small models, and on another layer we have the largest model with 1.5 trillion parameter size. By the way, there are two important factors in the large language model world. The first one is the parameter size. How many parameters does the model support or does it calculate with? The importance of that is the complexity of the model, and the more parameters it uses, the more complex questions or the more domain knowledge it can answer. Domain knowledge or vertical knowledge means that if there is a universal large language model able to answer questions like what does the weather look like now, then it has the capability to understand the question or semantically understand the question and give some kind of answer. But if we ask the model, how could you cure if I have a headache, or what should I do if I broke my neck, then it does not necessarily have the knowledge to answer that question. Or how do I manufacture this or that? Or what is the melting point of aluminium? It may not know that answer. However, we have external databases which can have the answer, and the large language model is a language interpreter, natural language interpreter, and we can use the external database to answer this question. We call this RAG, Retrieval Augmented Generation. This is extremely useful and extremely important nowadays. So, this large online model, and it is important that these models, these large models are online models, run in OpenAI, Microsoft Azure, Amazon, and so on and so forth. They are really capable, and they have a lot of kind of domain knowledges. Those smaller models that we see here, so the nano models, by the way, the 5.2 or 5.3 model is really a capable model and can run on an iPhone, basically. So these mid-range models are not so knowledgeable on domain knowledges, however, those are fast and we can run it in an on-premise situation. So we can run it in our data center with a few GPUs. So these online models are in the cloud, those ones can be run in on-premise. When we see the same picture in April, so 1 month ago, we still see improvements in the model. What I'm talking about. The Grok 1, the Claude 3 Opus and so on, but those are mainly closed models that are cloud-based. However, the ones that I circled can be important for you. Why? Let us take a few minutes to discuss about that. So the DBRX is a really large model, mixture of experts, and it has a lot of built-in capability to understand the question. And when you want to build a chat model, for example, then it is really important to understand your customer or your internal people, what is the chat is talking about, or what is the chat is going about. When we are building a RAG system, so when we want to analyze a lot of data, for example, a lot of PDFs, PPTs, Word documents, then it is really important to make a comprehensive understanding of 1,000 pages or 1 million pages. And in that, the DBRX can be the best. However, because of the parameter size, it requires a lot of GPUs. So this is a challenge. The more GPUs it requires, the more money it costs. So it's really a challenge. By the way, in our proof of concept, we don't tend to use this DBRX because this is too expensive. The other one, for example, the Llama 3 is 1 month old, and we are happy with that. However, its main purpose is an English-speaking model. I mean, it speaks somehow Romanian, Hungarian, Slovenian, Slovakian, and other languages. However, it always wants to translate it back to the English language, which is not so good. The best model nowadays seems to be this mixed trap, A by 7B, so it's a mixture of experts and it is a mixture of 8 models. It always chooses 2 models to answer the question. It is some kind of mid-range model, really good in interpretation, and does not consume a lot of GPUs. There are a lot of other ones in the smaller spaces. I want to emphasize Mamba or Jamba, which is the next model after Mamba, which is good because if you put here a large context, a large amount of text to understand, then it scales linearly, so it will not go exponential on the runtime. And the Phi 3 or Phi 2, as I mentioned, it can run on 4, so you can build various use cases based on it. In the CE region, we concentrate on 4 proof of concepts or 4 use cases. The first, and we divide it into 2 sections. The first section is computer vision to the left, and the other one is the large language model to the right. Just a second, I'm reducing the microphone. Okay, so on the computer vision side, you see here that there is a picture, very bad quality. We intentionally don't want to make a 4K picture resolution and understanding what's in the picture. So for an agri company and also for defense, we made that picture recognition and object detection proof of concept, and we are going well, so we know a lot of things about it. The other one is video recognition. It's a motorbike track, and we wanted to track the KTM motorbike on the video. It can also be used for drones and other use cases. So we can show you these computer vision proofs of concepts. On the right side, we use large language models in 2 cases. The first case is really a simple one, chatbot. So it's a simple chatbot with a RAG. So the retrieval augmented generation, which means that we want to feed the chatbot with company data. So it is running on premises in your data center, and it can process the policies, internal policies, the HR policies, some business processes, and so on and so forth. And you can ask questions through the chatbot. How large dog can be brought into the company without of leash or whatever? Or can I bring my kid to the workplace or something like that? So, or what server type does that have or something similar? So it's really a simple chatbot with augmented generation based on documents. You cannot see here, but here are a lot of documents, PDF, PPTs, and others. So it's basically chat with your documents. The other use case here at the bottom is a more complex one, and I will show you what this is about. I'm talking about a contact center solution and proof of concept, which is an end-to-end communication solution for automating the emails and email answers. So let's talk about that. This proof of context is an automated contact center email communication and processing system. So an email comes in, we want to process it, we want to extract the information from the email, and then suggest an answer for the agent, for the human agent. What is the email that should be sent back to the customer? So the situation, let me talk a bit about the situation. You don't need to read all this feature. So we are talking about 300,000 emails per year. That is the incoming rate. It's a, let's say, it's a mid-range insurance company that we are talking about. We want to integrate it with CRM systems, with BI systems, SQLs, and so on and so forth. We want to be compliant with AI Act, GDPR, bank security, and others. And the benefit is that it will increase the customer value, it will increase the throughput, and we can put additional services onto our agents. Okay, so it's integrated. The other important questions are that if we are doing that in, let's say, Romanian language, then why don't we do it in Slovakian or Czech or North Macedonian or other languages? Because sometimes the multilingual capability is in there. Just we need to harness it. In other terms, it is as easy to make it in Romania as it making it Slovenian or adding another layer on the website, for example. So it's really, it can be really important. Another important point that some customers say that, okay, I am used to the Excel sheets, I am used to the forms in the PDFs, for example, and let's give our customers the form to fill in, or let's digest an Excel table, because that will be the most effective way of communication. But this is not true, and this is important. So the natural language processing that we are talking about when doing large language models, the natural language processing understands the natural language. It does not understand the Excel sheets. It's really important. In the Excel sheet, you can make much more than the large language model would understand. So we need to convert it if there is some intention. Okay, we don't need algorithm and other. We can accommodate to terms and conditions, to written language, to policies or anything like that. So we don't need very hardcore developers to develop this solution, because the development is not so Python heavy, but it is more like flow engineering. And the flow engineering will be the next big step in the AI development. We can do multimodality. In this proof of concept, we only do text, but we can add images and others. And we want to scale very well with the customer's expectations. So this is this session point. And one more thing to consider is that the customer wants an on-premise system or a cloud-based system. It's really important because of the costs. As you may guess, the on-premise system is CapEx heavy, so we need to secure a lot of funds in order to make it happen. And we want to prepare the system for AI-enabled workflows. That's also important because we don't want to change the algorithm each and every time. We want to be prepared to be changing from time to time, from day to day, and the system should be able to track those changes based on the documents that we feed in, the same documents that the humans can also process. Okay, and this is the workflow, so it's an example workflow. The customer email comes in, we extract the information from that, so it's an insurance company. For example, it can be a claim about an accident, it can be a complaint, and it can be an urgent road assistance. We categorize the email automatically, whether it is a complaint, road assistance, or a claim. And if it's a complaint, then automatically let's make an SQL request, just because we can. I mean, we wanted to show the capabilities of the system. If it's a claim, then we extract more information. We compare the information based on the knowledge base, based on our policies, and based on the business requirements. So there is no algorithm, it's only flow engineering. So the large language model will compare the information based on these gray boxes and based on the letter from the customer. And if the information is enough, then we prepare an answer. If it's not enough, then we also prepare an answer asking for more details about the accident or the claim. Okay, so also you don't need to read this. I just wanted to show that here is in English, there is in Hungarian on the other, on the right side, and in the next slide we have here the Slovenian language. And this is the three example language that I wanted to show you. And also there is an assistance request, so urgent request, and the complaint on the right side is in English only, but it works the same. And here comes the important stuff. The orange ones are the responses from the large language model. For the large language model, we need to ask questions. It is called prompt engineering. We ask specific questions, so we don't program that in a specific way. just say that this is the question, answer on this question. So we asked about the summary of the accident, and it summarized that. Then in the next step, what is the sentiment of the person sending this claim? So this is the exact question how we get the sentiment from the email that I showed you previously. And it answers that the sender of this claim, Jane Doe, blah, 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 and it will answer it based on the email. Where does the event of the claim happen? And it will answer with a long sentence, so a human can read very easily this sentence. And at the end, I asked to categorize the email. What is the email type? Is it a complaint, it is a new accident, or assistance needed? So it is also automatically done. It is in Slovenia, so it is the same, exactly the same, just in Slovenia. And also it is the same in Hungarian. If you compare the amount of text, then you can see that in Slovenia it is larger, in Hungarian it is a bit smaller, also in English it's smaller. Despite of the fact that I set the temperature to 0, so the creativity to 0, it depends from time to time what is the answer that it gives. So it does not give each and every time the same answer or the same question. Therefore, we need to analyze the complexity, we need to analyze the closeness, how close the answer is to the template, and with that we can fine-tune the system. Okay, and this one is also a prompt engineering. I did not ask it a very short sentence, so gather the data, but I specified this, and this is also prompt engineering. I specified what do I need. So, shortest possible format. Who put each answer into a new line, and so on and so forth. So I specified what do I want, what is the format I want, and it gave back the extracted data. And it is really good and really important that it can do the job, and we don't need to programmatically do regular extractions and large things in order to extract the information. We just need to invent a very good prompt based on our business need. And here you can see that what is the data extract, for example, no personal injury. And this will be an important thing because of the next things that I would like to talk about. Also, there is in Hungarian nobody injured, and in Slovenian, I don't speak Slovenian, so I don't know what's there. But no bila, push, or whatever, I think it means that no injury. Okay, so this is the data extraction based on the prompt that I did. Okay, just store this information for a bit. This is about the complaint. In the complaint workflow, I asked it to extract the complaint number, which is here, and I asked the system that make a SQL query based on the table scheme, and I gave it a table scheme. So this is the SQL databases, not the content, but the scheme of the tables, and asked based on that and based on that question to formulate an SQL query by itself. So if you are dreaming about reducing the PI SQL query creation time, then you can decrease from example for 2 weeks to 1 minute with this tool in order to make a proper SQL query. Okay, and based on the SQL query, we can move further with the Okay, back to the claim. I asked the system to make an answer based on potential gaps in the claim. What is not correct in the claim of the customer. And the system answers that the mandatory information that is missing is the personal injury details, blah 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 blah. And here is the external mail. So I asked the system to make an external mail based on the information, based on the policy, based on the knowledge base and everything, make a mail. I did not touch any part of that mail. I just made a proper prompt, and based on the prompt, it answered me with that mail that I can copy paste into my mail system and send it out. And the thing that I mentioned will be important personal injury details. Although you initial report stated no personal injury, could you please confirm blah blah blah? And this is because I specified in the company policy, I mean in the process, that the customer needs to confirm another time that no personal injury happened. So we defined it also in the text description of the company policies. Okay, the same in Hungary. I just wanted to pinpoint one thing. In Hungarian, we have two ways to think about the whole thing. Either we run the model in Hungarian language, and this is completely good, and it can formulate an email based on Hungarian language, based on Hungarian email, so it's very good. However, the accuracy is not so good, and it needs to be enhanced. Let me show you something. Here is with red. If there were personal injuries, however, we remember that the customer stated there were no personal injury. So he did not understand in Hungarian language this subtle thing that there were no personal injury. So therefore, we made it everything into English. We translated everything into English. Based on the English corpus, we processed the whole workflow, and then we translated back into Hungarian language this one, and saying that despite of the fact that the original report says there were no personal injury, please confirm, blah 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 blah. Okay, so we can do a level of conversion when you don't want to make a fine tuning. Why is it important? Because we executing the large language models, then the budget requirement is pretty small. If you want to fine tune it to Romanian language, because Romanian language is not within the top 10, neither the other languages in the CEE. So if you want to fine tune it to Romanian, then you need to put a lot of resources in there, GPUs, software developers, and also data. So it will be a bit more expensive. So if you find that the accuracy of your model is not good enough, then you can do a double conversion. The good thing is with the double conversion that is support around 400 languages, so you can make a worldwide service with no additional cost. If you make it to Romania, you can make it to Taiwanese as well. Yeah, it's everything offline that I show you. It's offline. Yeah. No, it does not require online services to run. Sorry. In Slovenia, this particular thing did not appear in Slovenia. It appeared only in Hungarian language. But maybe another thing could happen in Slovenian language. So the corpus size, the dataset size in Slovenian and also in Hungarian is pretty small compared to the English corpus. So the accuracy is worse. Yes. Yeah, I would say that I did not bring you the application code, but basically it is a code level that can be written by a high school student. So really no complexities, no matrix manipulations under just a second. And it means that those are 4 cycles if that else, and that's it. Only if that else is when there is a categorization. If the category is one, then go that way. If the category is the other, then go the other way. So it's based on flow engineering and not algorithmic solutions. Yeah, so if there is any error when translating twice the sentences, Yes.
Especially for Romania, with 8 issues. Regional business centers,
Yes. Yes, exactly. So in translation, we can use two methods. Either we use the large language models translation, or we use the Google translation. I mean the Google one, which is called MATLAB, which can be downloaded. It's a 10 billion model that we use, and it's pretty good. However, this lacks the contextual information, and because of that reason, sometimes it is not so good. So we need to fine-tune the translation model onto our language, but this will be much more cheaper than fine-tuning the large language model. I used the original model, the Mixcal 8 by 22 billion. I did not fine-tune it for Hungarian or Slovenian language. I just used that model. And when I realized that in Hungarian it does not perform very well with the real answer, then I used the Google's MATLAB model to translate it from the English answer of the large language model to Hungarian. Okay, so in Slovenian language I used the Google Translator, and it was pretty good. I mean, I translated that back to Hungarian and English, and it was really good, so I did not realize that there are errors in either the original Slovenian language, so the original Slovenian, or the English translated to Slovenian. You can see that the format is very different, the content can be a bit different, but basically the adherence to the business processes should be the same, and I think that okay, so how do we achieve the goals? As I mentioned, we use for processing an 8 by 22 billion model that requires 4 GPUs at least. So 4 times A100 or 4 times H100 or 4 times L40S GPUs. I also use the T5-based large language model, which is the Google MATLAB. You can freely download it from Hyperspace, so you can use it. We did everything on premises. Nothing was run in the cloud, so everything on premises. And if you want to put there additional layer, we can use the ML solutions with ML Flow, ClearML, or OpenShift AI. So basically, it is a really good solution. However, I would like to raise your attention to 2 things. The first one is prompt engineering that I already mentioned several times, and the other is the flow engineering that I also mentioned here once. So prompt engineering requires that you know, I mean, when doing prompt engineering, you need to be like a Romanian language teacher or like a philosopher. And not a programmer or not a doctor or whatever, because you need to specify what do you want, how do you want it, and what is the expectation based on the things. And for example, you can parameter the language with the language variable that I also use. So it is really easy to make multilingual solution. The other one is the flow engineering, and here is a code snippet from the code. So here is the chain involved, because I did it in LangChain. By the way, there is LangChain, LangGraph, and Llama Index, which is the best solution for these kind of solutions. And you can see here the question and the phrasing of the question. You are an insurance company assistant agent, blah, 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 blah. Here is the return, here is the data from the customer, here is the previous result. So I assemble the prompt and then give the prompt to the chain, and then the result from that large language model run will come to the email to the agent that should be sent to the customer. So no large tricks, really easy, really easy. So the flow engineering will be more important than the actual Python code. And if you want to talk about Dell's added value, then our added value is that we make teacher-ready solutions for you in order to make a lot of mistakes instead of you make those mistakes. We have the capability both on the software side and expert side and also on the hardware side to make a proof of concept and size a solution that you want. And we try to make it as close to do as you want. We make proof of concepts. So if you say to us that this is our business goal, this is the amount of money that we have, please find out if we can achieve this goal within that budget. Then we will do our best in proof of concept to make it. Okay, let's see a few AI trends. The first one is that application development transforms into flow engineering and prompt engineering, as I mentioned. So the Python coding is really important, but you don't need to understand the matrix multiplication. And this is, I think, it's a good news for the AI developers. The next one is the agentic approach. So we would like to use the agents in order to answer the question. What does it mean? That I pinpoint one large language model process to make a planning. How would you answer this question? Then it will make a plan. Then based on your plan, go to another agent, and to another agent, and make the solving steps, get the results or gather the results, and assemble the answer for you. The catch here is that it requires much more resources, and we need a proper resource planning. However, the accuracy, the quality of the answer is much better. We want to use tools, for example, online search tools, for example, summarization, similarity scoring, or calculator or whatever. Okay, the memory. The memory is really important. If you want to make a personalized system and personalized solution, then we want to store the memory information from previous sessions and maybe user references. Okay, so when talking about the approaches, these were the model augmentation, so the retrieval augmented generation. Apart from that, we have the standard inferencing, fine-tuning, and model training. Let me tell you that 90% or 95% of the use cases is that. So retrieval augmented generation, it's really important. If we want to make it fast, then we have an alternative to go with NVIDIA. NVIDIA AI Enterprise license contains a lot of containers like data curation, like the large language model itself, a data aligner, inferencing servers, and others, which will speed up the development. But on the other hand, it's more expensive than nothing, so more expensive than the high-phase architecture. If you are talking about a complete system, here is some kind of I don't want to say blueprint of a system, but basically a draft of a system. Then in many times we think about only these blue boxes because those do the inferencing. Those are the things that actually run the large language models. However, we need RAG appliance, we need other developer clusters, we need a testing engine. It's really important to continuously test the quality of the model, of the data that you curate. And one more, I know that everything is important, but this is also important if you open the channel towards the external customers, then you need to protect it. It is really easy to inject additional code or somehow divert the conversation. So for that, you need firewalls, you need guardrails, and you need to pay attention to it. Okay, regarding the frameworks, what are the frameworks that we can use? As I mentioned, we can use LangChain, which is really flexible and agent-ready. We can use Lava Index, which I really like because it is easy to use and we can develop proof of concept very fast. really effective in the RAG-oriented workloads. And we can use the NEMO, which is the NVIDIA way of going. In the beginning, you need to decide whether you go the Hugging Face or the free curve or the NVIDIA NEMO word, because it can be really different on price-wise and also application development. And in the US, there is a case like I don't know. Regarding performance, the performance is a question, is a big question every time. So when talking about performance, many customers going towards VLLM or Tensor VLLM, which is the NVIDIA-backed solution. Yeah. Okay, 5 minutes more. Okay. And if you want the utmost performance, then use those two things. If you don't want to use performance because you want to build prototypes, then you don't need those frameworks. Regarding retrieval augmented generation, what is the vector database that you want to look for? So either we use Spice or Chroma or Mirrorloops, because those three are the most friendly solutions, I think, in the vector databases. The vector databases are required because you need to translate your company documents, company documentation to a vectorial format, because the GPU can understand only the vectors and make the dot products from those vector databases. So you want to define or choose what you want to use for. Redis is really a good enterprise-grade solution, and PG Vector is an emerging solution. Many people like it because of the postgraduate background. Okay, regarding MLOps, really fast. As I mentioned, we have a lot of options. One of the options is the Redshift, not Redshift, OpenShift AI solution, which is a kind of a low-code solution on the workflow designer phase. It can be good. On the other hand, we have MLflow, which is basically free, Kubeflow or ClearML, which is a bit more expensive. And going that at OpenShift AI, then I would raise your attention that the whole Red Hat ecosystem is really good and really capable. However, it is really hard to squeeze it onto one or two hosts. So if you want to start small, then MLflow and Ubuntu will be your friends. If you need a larger system, then maybe Red Hat and OpenShift will be your friends. And here is kind of an MLOps flowchart, and you can see here how many pipelines are here, how many interactions are here, from the monitoring to the model development for the developers, data pipeline for the data curators. So there is a lot of interactions. The larger the system, the more you need the models. As I mentioned, you will need guardrails when you want to protect your digital channel, and it is really, really important to guardrail your digital channels. You can either use NEMO guardrails, you can also use the Llama Guard, from which there will be a Llama Guard version 2 soon. You can use and you should use the prompt engineering and other external things. For example, we have solutions which can be used for contact center vocal communication, and this is good because when a customer comes in saying that, hey, I am Joe, and by the way, he is not Joe, but he's Jack, then we want to know or at least notify the agent that somebody on the other end is falsifying the personal information. Yeah.
How can a system actually detect this kind of impersonation?
It's basically a lie detector. So it's based on voice, I mean the voice speech, and yes, it is not 100% accurate. So the question was, how can it detect that it is another person? So if you are comfortable with lying, then it will not detect you. But when we are lying, then our voices are sometimes higher, or we do a lot of spaces, and so on and so forth. I don't know the details of the system, but we sell it for contact centers, and also it can be used for deep fakes or against deep fakes when when the computer generates the voice or the voice of Jack or John, I don't know what. So the original person's voice is the deep generated by computer. Okay. And if we want to make a whole system with guardrails, and NVIDIA offers us with the NVIDIA AI Enterprise and the whole ecosystem to place the guardrails in several places and place the microservices around that. So it's really important to not only firewall the system one end, but to make it very fast. Okay, and sizing, I just want to frighten you a bit, sorry for that. So if we size it for too large, for example, 10 sessions in parallel, then and 3 seconds response time, then the outcome will be 3 times 8 GPU system. That will be expensive. So I really encourage you to not to make the expectations too high, because otherwise the system cost can be also high. And it's just a comparison between the Llama 2, the big models. So the Llama is really good in quality, however the latency is really high. The other models, quality is not so good as Llamas, but the latency is much better. So I think that you may want to somehow go through the accuracy and the pipeline. And as last, I would like to show you the DELL Data Lakehouse solution card with some additional components. So when we want to acquire data from external data sources, then it is really a handy tool to have a system that is easy to use in AI environments and can support a lot of data sources, a lot of data integration possibilities. I don't want to talk about the hardware layer because I think that you can imagine that Dell can cover from the networking to the server to the storage to the clients, everything to the backup, which is really also important. And on top of that, we can build the whole ecosystem and also make optimization, for example, with OpenGetty and OpenVino in order to shrink the codes and make it optimized for your own purposes. And monitoring is one of the most important things, because that is the most expensive GPU that is sitting idle and you cannot use it. And with that, I would like to thank you for your attention and give the 2 presents to the 2 first question makers. Thank you. Thank you for your attention.